Okay, so today we are going to go through and look at what Python is, and then we'll go through some kind of uh, exercise as to the very much basics of Python, how we'll use it in your job when you get into a job, uh, or how will you use it in your real life just to automate stuff around your house. So people start with it as a hobby too. So people who don't have a Python background, sometimes they learn it for their job. Sometimes they learn just to automate things around their house. For example, I've seen people uh, build uh, the Raspberry Pis, which is a small computer which you get for like 5,000 rupees, and then you can make it do stuff automatically in your house, like turn off and turn on your lights, like message whenever somebody opens the house. You can make it automatically turn on and turn off the TV at certain point of time, monitor your internet traffic. So people do it for a hobby as well. But why Python, right? So there are so many programming languages, like around 100 plus programming languages are there, and out of which 20 plus are really popular. So people use them for different things. Why Python and what Python is, right? So let's learn about that. First thing is it's a high level language. Um, if you don't know what a high level language is, that means you don't write it at the computer level. So each computer is different. So if you have a computer that is like Intel P5 versus a Core i7 10th generation versus you have a AMD processor computer, and another person has a Mac which has a M1 chip. So the computers are all completely different. So when you write a programming language, then you talk to the computer. When you write that language, it needs to, like, each computer needs to understand it. But to talk to different computers, you will have to write different code. So that's how the first programming language used to be written. So each like assembler or the core chip inside your computer will have its own coding logic, and you'll write assembler language specific to that computer. So that was called low level languages. Later, we changed into like C++, Python, Java. Those are high level languages. And the reason these are high level languages is you don't write code specific to those assemblers, those particular uh, chipsets. You don't worry about whether you have a Linux or a Windows or a Mac OS. You don't worry about whether you have a Pentium processor or a Intel Core i10 or it's a M1 Apple processor. You don't bother about it. Or if it's a phone with a like Android OS, you don't bother about any of that. We write the code in a high level language. So that's the reason like all these languages are high level. So it's not just Python, so many other languages are high level. So what else is Python's specific things? It's interpreted. That is like we like we there are two types of languages. Some languages get compiled. So when we write code in Python, it gets interpreted. That is, we don't have to compile it once, then have the compiled code for that particular computer, and then run that particular code. So when you run Python, it during runtime it gets adopted from the language you write, the code you write, to the actual machine it's running on. So it gets adapted during runtime. So when you actually run the job or run a Python script, at that time it gets interpreted for that particular computer, whether it's going to be your phone or whether it's going to be a computer. It gets interpreted for that particular uh, technology, and then it runs. So it takes some time. uh, it takes slightly longer than say a C code. If you write a C code, it first get compiled, and then when you compile it, it gets the assembly language for that particular computer gets written. So when you compile it on a Mac, you'll get a different output. When you compile it on a Windows, you get a different output. And that particular compiled output you run on that particular machine, then it runs. So that's how C works. But in Python, it's interpreted. That is all this. It doesn't actually have to get compiled and then get interpreted, and then get run. It is interpreted during runtime, and then it runs for that particular computer. It's a scripting language. That is, you can write code uh, in an order and tell it to do certain things, and then exit it, return it. So those kind of things can be done using Python. So it's a scripting language. And this is not a new language, even though Python has been very popular in the last 5 to 10 years. This has been developed in 1980s. Uh, Guido van Rossum, he's still he's a researcher from Netherlands, and he still is helping out the Python projects. So he's still there as one of the advisors to help with any kind of changes that Python is happening. The Python versions keep changing every couple of months. The latest one I think is 3.10. I'm still using Python 3.8. Um, Most of my uh, clients that I work with, they use Python 3.7. Some of them even use version 2. Um, so Python version 2 was released in 2000. Before that, Python was very basic. Before 2000, Python was one of the good programming languages, but is not as popular. Um, Python 2 changed that game in 2000, and then uh, there was 3.x that came in after 2008. So that's where Python started taking off. So after Python version 3, um, now all these subversions 3.1, 3.2, 3.7, 3.8, and I think the latest one is 3.10. All these are like very easy to use, and that's one reason why Python's become very popular. Any questions at this point? Should I keep continuing? Yeah, I can hear you. Oh, okay. Let's keep going on. The next, okay. Um, from the next session onwards, we'll keep it a little interactive. I understand you both of you don't have too much of a background on Python, so I'm going to ask a few questions today, and we'll keep it slightly interactive. From the next session onwards, we'll keep it even more interactive. Um, so why do you choose Python, right? So I've put in some points here. Why don't you say it from your perspective? Like, this is something which is general, right? Why do you, like, you've heard of Python, that's why you're learning Python. So why do you think like you would choose? You can look at what is on the screen as well, and tell me, why do you think you heard about Python, or you think Python is the language to learn? Venkatesh, you want to go first? No. Yeah. Okay. Okay, that's very good. So I'll add on to what Venkatesh just said. So he talked about automation, right? So that's something a lot of people do. So even though it's not part of their work, they learn Python so that it can automate their work, make it easier. So there are some analysts who write Excel formulas. So for them, that's their work. They come in, make the formulas, make sure it works, and then submit the Excel, send it over by email, and go. But when they learned about Python, they were able to automate that work, do that much quicker, and then free up their time for other things, right? So they can take up more work, or they can take up managerial roles. So that kind of helped them. So this is like whatever Venkatesh is saying is an example I've seen in my life play out a lot of times. And Python is easier to learn. Like he spoke about C# and other languages. Like all these languages are very good, in the sense that they have the most advanced libraries. They have a lot of plugins that already people have written, and then we can use those libraries that people have written in, and then we can use that to do a lot of stuff. So this extensive library is a huge advantage. And not only Python, like C# also has that. But the one edge that like just comparing Python and C# is a .NET language. So Microsoft Technologies is where it is uh, it shines. So it does very well when you use Microsoft technology. So if you use a SQL Server, which is Microsoft's, if you use a .NET Server, which is Microsoft's, C# has all the libraries to do all the work in those spaces. But Python has extensive libraries for like data science, like data management. It has very good libraries for like web. If you want to set up your own website, so they have libraries for that. So those kind of things people have created. Most of these projects are open source. Like people who are working on Python just wanted to build out something, so they built it, and then it gave that library over to for everybody to use. That's another thing. So Python is free, Python is portable. So that's another thing, reason why Python is very popular, and why you should choose Python. So Prem, from your perspective, right, what do you think, you did you hear about Python from somebody else? How did you choose on Python, or what kind of uh, pulled you over to choose Python? Okay. Yeah, the way Python is, I think you covered most of everything else. The only one part that you added on is easy to learn, right? So I'll just add on that. So one way, like when you compare to Java, Java is very strict on like uh, declaring your variables, declaring your classes, declaring your inputs, outputs. Uh, Python keeps it easier in the sense that you don't have to declare your variables explicitly. So you don't have to say this is an integer type variable. This is a string type variable. You don't have to do anything like that. We can directly start with the code. You can assign an integer I equal to 1, and then you can start coding in. So you learn that is much easier than the stricter rules that Java has. And Java has its own advantages because it's stricter. You kind of in certain ways avoid errors, but it is easier to learn Python, and less easier to use. And I earlier spoke about interpreted language. So, like something like a C or C++ or a C# is first compiled, and then it is run. Even in Java, we have a compile step, and then we have to have a Java virtual machine to actually run the Java code. So it's done in those steps. But Python is actually an interpreted language, so you can't use it for really fast applications. If you want to do some things really fast, you probably have to go for a non-interpreted language like C. But things when speed is important, but you can do away with ease of use. People use Python a lot. So if you have not installed Python, I'm assuming both of you are using Windows computers. Is that true? So yeah, like I would suggest using something called Visual Studio Code, um, which is available. You can either go to like this URL python.org/downloads, and then you can pull out the latest version and download it, and then install one of the IDEs. So this is what I'm showing here is Microsoft Visual Studio Code. Um, like there are other options like Thorny, PyCharm, Spider, Anaconda. These are mainly for data scientists. PyCharm is very good, and you can do a lot of things with it, including data science work and data engineering work. Visual Studio's code is easier to adapt, and say if you're not only if you're coding with Python today and tomorrow you want to code with something else, you can do that. It's probably easier to start, and Thorny is very lightweight. I like that too. So if you're sure you're not going to do anything else other than Python, you're just going to do Python code and run it, you can start with Thorny. It's very lightweight. You can do one of any of this, but what I use every day is I use Visual Studio Code. I used to use Spider and PyCharm in earlier roles, uh, but currently I stick to Visual Studio Code because that's what we use at work most of the time. So like I'll give you an assignment to complete a Python program. It will be very easy because it's a first class. So before that, you'll have to go to this link, download it, and then download Visual Studio Code, install that. So you'll have to do a Python installation and either Visual Studio or one of the other IDEs. If you don't want to do Visual Studio Code, you can do one of the other things. Install that. And next week when you come, after that you'll have to write the program, and then we can either check the code by sharing a screen, or if you have any problems running the code, we'll probably work on fixing that during the next class. Okay. For say you're not able to run your Python code, then you can actually use these tools. These are on the browser, so you can go to your browser, and then you can do replit, and then that will you can actually use Python there. So you can actually write your code here and execute it here. So if you say print, so you can do all that here. So you can write your code in the left and then print it out here. So all this can be done online. There are some links that I've provided here. You could do that there as well. But given that you want to go on a like path towards learning Python, uh, it would be easier if you have one of the IDEs. Next is next thing I want to cover is the keywords. So this is kind of where we start with Python. So when we write a Python code or any code, for instance, the computer has to understand what those words mean. So when you talk in English, each word has a meaning, and we talk in sentences, and after each sentence, when we write down, we have a period or a full stop, and then we start the next sentence. And within like each word has a meaning, and when we write the words together in a certain order, it means something else. If I change the order of the words, it would mean something completely different. So that's how Python works as well. So to the computer, all these are words, and so Python has to understand those words. And if you write import and you write keyword, that means it has to import a library called keyword, and certain libraries are already built in with Python. So when you install the Python, it already comes with certain libraries. So when you do the import keyword, this is not something you have to install in addition to Python. This comes with Python, so you don't have to in addition install it. But when you actually do like say data science work, or you want to interact with MySQL database, or you want to do something with respect to uh, AutoCAD design. So you want to go into AutoCAD and update something. So there might be a library somebody wrote about AutoCAD. You'll have to first install that library, and then when you write your code, you'll have to import that library, and then you can use the words in that library here. So first we are importing in this like a sentence in English. This one line is a set of commands that Python will understand to be one set of commands. When we move to the next line, it understands that it's a next set of commands. It's like a next sentence in English. So this would be understood as a next sentence. So what we're doing here is we're importing the keyword library, which is an internal Python library, which has all the keywords that Python uses, and then we're going to print it. So this is just a print, and within that, uh, in the library, we're calling the list called KW list. List is a Python data structure which has a list of elements. So that's all you need to know for now. We'll go through that later. And then we are going to print that. So this print command just prints those things. So if we execute this, so we get back a list. A list is something that has all the values inside it. So these are all the values uh, that are part of keywords. So if you see, there are only 33 keywords in Python. Everything else are not keywords. So everything else is like something you can assign as variables or use elsewhere. But these are keywords that Python understands to have certain meanings, and those cannot be used as like a variable name or anything else. So if you see this, these three false, true, and none are the only ones which have uppercase and lowercase in them. And Python is very case sensitive. So you have to write. So I cannot write uh, import here with an I capital. It wouldn't understand what I'm saying. So it doesn't understand what I'm saying. So I have to be case sensitive. So everything I write here, I need to use the right case. That is, I need to use the lower case for all these keywords. These are the only three keywords where you can actually have uppercase mixed in them. Everything else is just a lowercase keywords. So here we are just going to look at some kind of logic. There are some logic operations that Python does, and just to understand what a keyword is and how you can use keywords together to actually make a make a make a statement. So statement is like a sentence in English. So where you have set of um, keywords together, or a keyword and some variable names together. So here we are using three keywords. We're trying to use the AND statement. So if you know what the AND logic is, uh, for any basic computer science you would have learned. So this is false and true would mean like it's doing an AND operation between a false and a true, and AND works only when both are true. That is, if the left side and the right side are true, then it would return a true. If I say false and false, or false and true, it would return a false. The only case when it will return a true would be when both sides are true. So that's kind of a logic operation. And the reason I'm bringing this here is to understand that you can put together keywords to actually execute something. So you can actually make it understand these three keywords and how they work with each other. An OR statement works similarly. If one of them is true, then it would return a true. So in this case, the left side is true, so we're going to get back a true. So that gets us to what a statement is. Statement, there are multiple types of statement. We just saw one, but instructions that a Python interpreter can execute is called a statement. So here I want to stop. Like, let me ask you, like, Prem, I'll start with you this time. So yeah, so what do you think this does? Like, I'm having an assignment statement. I call it an assignment statement, and I'm having a equal to 1. What do you think Python will understand based on this? Sorry. Yeah, in this example, what happens is the value 1, which is a number, gets assigned to the variable a. So have you worked in any other programming languages, or this is your first exposure? Okay. So in this case, what's happening is, like, kind of, it's a two-step process. But this number 1, which is a number that anybody can understand. So Python understands that to be a number, so it doesn't get confused. So it takes that, it sees an assignment operator which is an equal to, and then it assigns that value 1 to a. So when you do this assignment, so in the memory location a, the value 1 is being assigned, and then somebody later uses that variable, whether to print it or to do something else with it. It will have, when you use the value variable a, it will have the value 1. So Venkatesh, I'll ask you this. So when I talked about memory location and it gets stored, right? Like, do you know what is a memory versus your hard disk versus RAM? What am I talking about here? Would you know? That's okay. That's okay. That's why we're here to understand. So, like, within the within the value a, we stored the within the variable a, we stored the value 1. But what Python did is, so in your memory, so what is memory is your RAM is your memory, and your hard disk is more persistent storage, and your RAM in your computer or your phone. So when you buy your phone, you have like 8 GB RAM or something, right? So that's what any program that runs on your computer uh, would use when you actually assign this and use this. So any program that you write on your phone or your computer, um, when they assign this, it gets assigned on the RAM, or that's what we call memory. So let's understand how it actually assigns it. So there are two pieces to this. One is an ID, which is a location in the memory where this gets assigned. And not only that, when I said one is a, if it's another programming language, I would say int I equal to a, to say that this is an integer type. So in this case, Python understands that, okay, this is an integer, so I'm not going to get confused what this variable is. So I'm going to assign this to be an integer. So it has something called a type. So whenever we just write one statement called a equal to 1, in the backend, it assigns a memory location to it, which we can find by calling the ID. So when we find ID of a, so this particular command which we called ID of a, what it does is it tells us which memory location your computer has allocated a to. So your computer right now has allocated this memory location 11496640, which is in the RAM. There is one particular address. So this is called an address. So it actually tells you where A is. And then Python has also understood that this is a integer type. So it is assigned the type integer. So this is kind of an assignment which is a simple one-line task. But if you see that, it has done so many things within that. Is that understandable, Venkatesh? Okay. Okay. So yeah, yes. Yep, that's exactly what I wanted to explain. So very good. Okay, so that's one piece, right? So you understand how a statement works. Now we look at other statements where we are slightly different. So I'm going to cover those. So we saw that we wrote the statements like this, right? We wrote print a, then we wrote I equal to 7, and then we wrote print something else. So whenever we write statements, we just write them in the straight line. But there are certain cases where we don't do that. So we don't do it this way. We don't do everything in the same alignment. We do them like indented. So that's what I wanted to show here. So there are cases where we write like if statements, and then what we want the computer to do is we want it to just execute this portion, only the intended portion, and then when it's done with everything, I want it to do done. So whatever I wanted to say here, so here say if I want to say print true, so whatever I want to say only when something is true. Say for example, we know that I is or let's do this, let's say I is 100, and I'm saying if I is less than 200, then like this particular condition, if I write it like this, Python won't know what it should do when the if condition is true. So when we indent it, so now what Python understands is that if this is true, if there are like so many lines here, like there are 2 lines here, these 2 lines have to be done when this condition is met, and this has to be done no matter what. Like when after this whole if block is done, so this is called an if block, and this if block is intended because it wants Python to know that these particular statements have to be completed only when this is true. So I'm going to also do another if statement and say I is greater than 200, and I'm going to have 2 statements there. So when I execute this, first it assigns the value 100 to a memory location assigned for I, and then it checks whether that I is less than 200. In this case it is, so it'll execute these 2 statements, which are the intended statements for this if block, and then it'll come to the next if statement and it'll see if I is greater than 200, which it is not. So it'll ignore all these intended statements, and then it'll go here and print the last statement. So that's what I expect it to do. So we'll see what it does. So if you see, what happened is it went to this statement, printed true, then it went to this statement, printed 1, and it did not do these 2 because this if statement was not satisfied, and at the end it print done. So that's what this indentation is used for. So we typically use statements which are 1 line and like one after the other, but whenever we want to do certain cases, then we do it this way. There are also other cases where we do it. One is called a for loop. So whenever we want to do something 10 times, then we can ask it to do it this way, and then so if I wanted to print the values 1 to 10, actually this is how I should do it. If I want to print the values 1 to 10, then I go through this loop. So it does a for loop 10 times, and then it prints each number out. and in this case, this actually returns 0 to 9. So I'm just adding 1 to each of the number to print 1 to 10. And then if you see, it prints the values 1 to 10. So in this case also we use indentation. So we want for loop to run, and we want these intended statements to run. So not only this, if I want like other statements, I add them here, but I add them in the intended indented way. Those get executed. So if you want these 4 statements to run, then I give those 4 statements indented, and all those 4 statements get executed multiple times until this for loop is true. Okay, so that's something where we use indentation. Okay, so earlier I said each statement is written in a line typically. In one line, there's one statement. But if you see in this case, we had to use 2 lines. Say this is a list of vowels and you don't have space in the first line, or if it's a list of like all the capital cities in the world and there are like 190 of them, you don't fit it in one line, then you can actually use multiple lines to do that. And this is also like Python doesn't like Python understands this as one line until you go and like for example we open this braces, until you end this brace or a square bracket, Python waits for you to complete that to understand that this statement is complete. So for Python, this whole thing is one statement. Even though you write it as part of 2 lines or say 5 lines, Python still understands that to be one statement. So we also do this with other things like string additions. Say we want to write a long string, then we do it like this. We do it in multiple lines. So this is this thing. So we can't finish the sentence here. So we go to the next line, and then we add in the next set of things. This Python still understands as one line. So I really have to put in a continuation here. So it's throwing me an error right now. But there is a way to add multiple strings to get a long string. Okay, so I'll go back to a quick question to Prem. So Prem, so we this is a list. So we spoke about int, and now we're talking about list. So what do you think is a list? So this is a list. So if you look at this, right, what do you think is a list? So this is a list. This what we're doing here is we're assigning vowels. We're assigning a list of vowels to this type called vowels. So this is actually a list. So what do you think is a list? Like is if you don't know, that's okay. So essentially, a list is a set of elements. So this, if you see, this is a string A, this is a string E, this is string I. So we put them all together, and that is a list. In other languages, we call it an array, but it's not very different. The data structure is still um, the same. So whenever we print vowels, so this is let me first execute this, and then let me go ahead and print vowels, and then prints out those letters A, E, I, O, U within square brackets. So this one is a uh, set of or list of things that it stores in one memory location. Okay, so we will cover like vowels, I mean lists in very detail later because those are very useful. But the reason I wanted to get here and ask you what a vowel is, what a list is. I'm sorry, I didn't mean we'll cover vowels later. We'll cover lists later. Yeah, we'll cover lists later. But if you look at this class list, this is a very powerful set of tools that we have. But there is something about memory that we have to understand. So all these things, this might take a lot more memory than just storing one integer. One integer might take like 32 bits of memory. So it stores one memory location, and then it pulls it stores that information there. Here, when you type the print type of vowels, earlier when I ran it, it used it in this memory location. Now that I stored vowels again, I don't know if it stored it in a different location, so it stored it in a different memory location. So at this point in time in my RAM, it saw which empty location was there. It stored the value AEIOU in that, and then assigned the name vowels to this memory address location. So that's what it did. So it's a two-step process. Like Venkatesh, I think you got that when we spoke about ints. So it's a two-step process. It assigns the type there, and then it assigns that name, an address location, and in that address actually it stores this whole values. And the important yeah, the important thing you have to understand about list is it stores a lot more information. So it can't just have 32 bits like an integer. At this memory location, it has to store all this. So if this list is like in my case, right, I work as a data engineer. I store lists which have like a million items in it, and we need a memory location which has a million items in it. So I cannot easily just say, okay, move this list to this memory location and then use it. So I cannot assign that to a list and use it. I'll have to figure out a way of using a part of the list, and then using that as a list and then doing it. So that's something about memory, right? So when we use memory, we think about, okay, just let's just use this here. Yeah, for normal programs it works, but when we actually use it in real life for large data sets, we have to see if that memory location is sufficient for us to use that. Okay, we have about 15 minutes of class. So I just want to ask you, Venkatesh, Prem, you guys are comfortable going along? Do you have any questions before we go on to the last 15-20 minutes? Yes. Yes. No. Yeah, it is, everything is stored in this memory location. So the like so the so the A gets stored here, and immediately after this E gets stored and I gets stored, and that's how it gets stored. So everything is stored in starting in this memory location. So in this memory location and going forward, the whole list is stored. That's a good yes, exactly. Okay, so this is something called an assert statement. So we saw a lot of statements. So what I tried to do is the keywords that we saw, I tried to use those keywords today, and not go too much beyond that. Um, so there's something called assert statement. We typically use it for debugging purposes in real life, but I wanted to like show how we use that. Um, so in this statement, what we're doing here is we're assigning a vowel, let's say E, and then there's another assignment operator. Here what we're doing is we are doing a condition. Condition is something which condition is just a variable name. You can use whatever name here. Say I'll say C and D or something. Um, in this variable C and D, what I'm doing is I'm checking if vowel, that is this one, is in this list of vowels. Or let's say this is V. Let's not get confused with vowels because I named another thing vowels and I don't want to call this vowel and we don't know what is what. So I'm having this variable V and assigning the value E, and I'm using a condition like I'm using a variable, another variable, and asking if V is in this list. So that is E in this list? That's what I'm checking. So this would actually have a value true or false. In this case, because E is in this list, it will actually have the value true. If I print this value C and D, it will actually print the value, the Boolean value true, because it could either be true or false. But in this case, I'm just going to use E, so it's going to be true. If that is the case, it's going to print the message. Like if and I'm having another assignment called message. This is actually going to be a string, and then I'm assigning the value not a vowel. This is just a message that's going to get printed. Um, and this is going to be the last statement I'm going to execute, which is an assert statement. What this assert does is it checks this condition. The first piece of it is the condition, and after the comma, whatever we send will be the message. So that's what it will do. It will check this condition, and if this condition is met, it would not throw an error. But if this condition is not met, then it will throw this error. So I'm doing it this way. So let's simplify this program, but I'm going to start this way. Um, same does, like, are you following along till now, or do you want me to slow down and tell you something here? So V is having only one. Uh, yeah, only yes, correct. And in this place, I'm checking if V is in AIOU. Yeah, V is having one of these values. V is V in this means V is having one of these values. So that's what I'm checking. Um, and then this print command, this is printing this value, which is actually true. And then when it comes to the assert statement, it is not like it's finding this is actually true, so it's not even doing anything. When it's false, that's when it does something. So let me simplify this. So what I'm going to do is like I'm going to rewrite this statement. This is very Pythonic, but probably for a starter it may be difficult. So I'm going to do it this way. So I'm going to make this just two statements. I'm going to have an if statement. If um, v in or let's do this. If this is probably easier to understand. V in a. So I'm going to do it this way. So this is probably easier to understand. Um, So first we assign the value e to v, and then I'm going to do an if condition. I'm going to check whether this variable is in this list, and I'm going to make this I. So I'm going to check if this variable is in this list. If it is true, then I'm going to assign the value true to C and D. Else would just mean that's not true. So this condition is not true, then it comes to else. And if that is not true, then I'm going to assign the value false. And then I'm going to do an assert statement and see whether it's true. Assert statement, what it does is it checks the first statement. If it's true, it doesn't do anything. If it's false, then it does this. It prints this out. Okay, so that's good, right? So so if we run this, what happens is um, nothing will get printed because there's no print statement here except this assert statement. This assert statement would happen only when it's false, but in this case, because it's E, it goes into true. It does not do anything. So it should not do anything at all, and nothing would get outputted here. Instead of this, if I put a say L, what do you think will happen? Prem. Okay, it'll print that. Okay, yeah. So that's what it will print. This is just an assertion error. It says that we found this condition not met, but it did print the value not in vowels. Or you could do it this way, like if you are not actually debugging your program, you're actually you can actually print it here and say not in vowels. So you don't even have to use a assert statement, but I just wanted to show you how that gets used. So if we do it this way, so it just prints not in vowels, and when you put in a vowel like U or I, it prints this statement. So is that good? The next thing we need to understand is statements in Python are executed one after the other, and typically it goes through the lines, first line, then the second line, then the third line, then the fourth line. But these kind of things are exceptions where only if this condition is met, this block is executed. If there are 10 statements here, everything which is indented here will get executed only if this condition is met. And this will be executed only if this else will be executed only when if this condition is not met. So any one statement here or 10 statements here that you give indented will happen only when this is happening. But typically statements are executed one after the other. There are some exceptions and there are some cases where it's not. So we'll get there. So we started with identifiers today. So I want to kind of circle back there. Whatever Python identifiers are there, we cannot like use a keyword that we saw in the start of the class. Like we saw that there are so many keywords like true, false, none, global. Yeah. So all those things cannot be used as a variable names or as a like method name or a class name. So there are three things, right? We saw about variables today. There are two other things, those I will cover in the next class. Those are called methods and classes. So variables, methods, and classes, those are basic structures in Python with which we tell Python what to do. But whenever we use those, like these variables, we cannot use a keyword that was there in one of the lists. So for example, let me go back to that keyword. I cannot take any of the word, like I showed the global there, but I cannot use say lambda, or I cannot use if, I cannot use any of those as a variable name. So if I do that, so if I go back here and say lambda is equal to 1, so it throws me an error. It shows me an underline, and it's going to say invalid syntax. So it doesn't understand what this means. So Python interpreter will not be able to identify when you use these keywords as variable names and you can also not use them as method names. So methods are like functions. If you know other program languages, methods and functions, um, those are things. Those are kind of modules that get executed, and you can call them from somewhere. So here, when I said statements are executed one after the other, there's an exception, that is you can call a method. You can actually say um, like um, um, if you have a string, and then you can say um, these are all the methods that come in. So we know that I is an integer, so an integer has these kind of methods. You can use any of those, and that would so the method typically has open brackets and close brackets. And so if you use it this way, so this is called a method. Typically when you write a first method first time, you have to define it. So we use the def method name, and then we open brackets, close brackets, and then we tell what the method has to do inside the method. So here, when we write a new method, when we define a new method, we cannot use any of the keywords. So we cannot use global here, true here, or false here, or none here. You cannot use those things. So those things would not work. So that is something you need to remove with keywords. I mean, typically these are not things you have to learn over and over. This is just something you have to understand it when you start with Python. Same thing with classes. We can't use any of the keywords for class names. So everybody starts programming with hello world. So let's do that. So here what we're doing is we're assigning the value hello world to the string named a, and then I'm going to print the value of that. That is going to execute and print the value hello world. But one thing we understand here is this a, as we said, has to be lowercase. If I actually give print uppercase a, it does not know what I'm talking about. Similarly, when I assign the value uppercase a, and when I say it's hello world 2, and when I print hello world a, so it prints this value. It does not print the lowercase value. So it's very case sensitive. Remember last time when I printed the uppercase a, it through name is not defined, so it doesn't understand what this name is. It doesn't understand what this uppercase a is. Now that I've defined it again, if I run it again, it's going to print out the new value of a. I'll end this, like before our assignment, I'll end the course with naming conventions. So this is something that when you really get into projects, you'll have to use these naming conventions. Variables are named in certain ways in Python, and we follow that so that other Python programmers, if they see that code, they understand what you're writing, and that'll help them like interpret it easily. Um, for a Python compiler, your naming convention may not matter. So if I write capital AGE, your Python compiler will still work. Like we wrote print A, and then we assigned it to hello world 2. It worked. But when we typically write programs, we use these naming conventions. Whenever we use a normal variable, which is a public variable, we use lowercase. And if we want to have two parts to that variable name, like last name, first name, then we separate them with underscores. We don't say like last name. In Python, we always have lowercase variables for the whole lowercase characters for the whole name. There are something called private variables which we have to use when we use them in certain areas, but not like some other programs that call us should not know what it is. That's a private variable, but we'll dig into it deeper when we go later. So for those variables, we start with an underscore. So we say underscore ID or underscore um, name. So all those things, when we use those, we use the private variable to be starting with underscore. So we also use uppercase variables names that we use for constants. So things that don't change over the program, like pi or your database schema that you think is going to stay this constant during the program. It's not going to change. So those things we use, those are called constants. So those are variables, but we don't, we're not going to change it over the course of the program. So those things we typically give the uppercase letters to it. And Python need not, Python is not asking you to give these uppercase variables, but this is just a naming convention we use. So even if you say pi is equal to 3.14, Python is going to still keep it constant because you're not going to change the value of it. Uh, but it's just a convention for people to read the, who's reading the program, to understand, okay, this seems like a place where we have constants. So that's kind of where we understand. So to summarize, use only lowercase variables. Don't start with special characters like ampersand or dollar sign. Separator we use is underscore. We avoid names like X, Y, and T. We try to name them with reasonably understandable names like first name, last name. Private variables should start with an underscore. And like all constants, we typically have uppercase letters. That's the summary. Um, so the first assignment for today is going to be like, let me remove this for now. So is to write a program to get two numbers as input. So you can Google these questions. You can try it out from what we learned today, or you can get back to me if you have questions on WhatsApp. Uh, and like for next week, if if you can install Python, install the IDE, and then write your program to get two numbers. So just get two numbers as input and print the sum of those two numbers. So just print the addition of, it should print something like this: print the sum of 3 and 4 is 7. So something like this, if it can print, that's what we want the program to do. That's what I wanted to cover for today. Like first of all, how did it go? Like, was I too fast? Was I too slow? Was I going through certain facts faster, slower? What should did you did you get everything? And will you be able to do the assignment and get back next week? Venkatesh, why did we start? Okay, okay, okay. That's good. Okay, perfect. That's good. Prem, what do you think? Like, do you want me to go faster, slower? Did you understand? Okay, that's okay. That's okay. Yeah. Okay. And like next week, I'll go a little bit more in depth. So and we'll also start writing. We'll take a breakout session and we'll say, okay, let's write this program, and then we'll write it. Uh, like, and you guys might have to share your screen and okay, let's write it now, right? So we would have to do it that way. So that might get it slightly uh, slightly into the depth, right? So it will go like that. But this 16 sessions, whatever we do, will at the end of it, you guys should be able to easily do what we intend to do. That is, write a program, uh, like and go through advanced logics, calling advanced libraries as well. So you should be able to do all that. Okay, that's it. Muthu, Harish, anything else? Are you still there? Okay.